So what we are doing today is we're taking our radicals that we started last class, and we're going to be adding and subtracting them. So when we're adding and subtracting them, what we have to keep in mind is we have to look for like radicals, which is very similar to your like terms. So for example, if I have 3x and 4x squared, are those like terms? No, because you have an x and an x squared. Those aren't like terms. It's going to be very similar for our radicals. A like term has the same radicand, which if you remember, that's your number under the radical. Number under the radical, that's your radicand. So that number under that radical sign needs to be the same. And they need to have the same index. Who remembers where we can find the index? Aaron? In front of the radical sign. It's usually written right up there. That's your index. So it's got to make sure you have the same index also. So some examples would be 3 square root of 2 and negative 7 square root of 2. Those would be like radicals because our number underneath the radical is the same. Those are both a 2. And these are both square root signs. How do I know it's a square root sign? As opposed to like a cube root sign, which would look like this. Like if I had cube root of 4. There's a little invisible 2 that tells you it's a square root. They don't always write the 2 because the square root sign is so common. They always make sure to write it for the other ones, like our little cube root here. We got our little 3 as our index out there. So those little numbers out in front, if they're there, those need to be the same. So when we're adding and subtracting, you've got to have like radicals. If you do, you just add and subtract them and simplify if possible. If they're not the same, you need to make them the same, and then you can add them. So let's go through our examples here. Number 1, if I look at my radicals, are those the same? Yes, both radical 3's. So I'm going to add their coefficients together. What's 5 plus 7? So 12 radical 3 would be our final answer there. Your radical stays exactly the way it is since they're similar. Mm-hmm. So number 2, do we have like radicals? Yep. What's that number in front of our second radical? 1. We don't always write it, but there's a 1 there. So 8 minus 1 gives us 7 radical 5. All right, so how about for number 3 again? Let's look first. Do we have the same radicals? Yep, we got radical 2 and radical 2. There's a 1 out in front of that first radical 2 that's not written. So 1 plus 3. So we get 4 radical 2. That would be our answer for that one. Number 4, again, your thought process should be, do I have the same radicals? Sure do. I've got radical 5 and radical 5. Those are the same. So negative 3 minus a 4 gives us what? Negative 7 radical 5. Yes, ma'am? Because 1 plus 3 gives me 4. If there's no number in front of the radical, it's always a 1. We just don't always write that 1. Oh, you put an extra subtraction sign in here. It's just negative 3 minus 4. You did minus negative 4. Okay, number 5, do we have like radicals? Yep. Again, we have a 1 here, so 1 minus 5 would give us a negative 4. And then we have our radical 20. But that one stands out in my mind. Can we reduce a radical 20? Is there a perfect square that can go into 20? Yeah. We didn't do this for the other ones because a 3, a 5, and a 2, there's no perfect squares that go into those ones. There is a perfect square that goes into 20. What is it? 4. So 4 goes first, and then the 5 goes second. 4 times 5 gives us our 20. What is the square root of 4? 2. Bring down my radical 5. And again, what do I do with this negative 4 and this 2? Multiply them. So what's our final answer here? Negative 8 radical 5. So then our last one on the front, are all three of those same radicals? Yes. So we're going to add them together. 1 plus 3 minus 10. Negative 6 radical 7. So when they're already the same, easy peasy, you just combine them, add and subtract. Take a look at the back, and it is a little bit more difficult because our radicals are not the same this time. So in example 7, I have a radical 3 and I have a radical 12. Okay, I can't add those together. So what I have to do is I have to look to see if I can simplify those radicals. Can we simplify a 3 any further? No, there's no perfect square that goes into 3. Is there a perfect square that goes into 12? Yeah. 4, and then times 3. So again, the square root of 4 is 2. And then we keep that radical 3 after it. And then I'm going to bring down my 7 radical 3 plus in front of it. Now do we have like radicals? Yes, now we have both radical 3's. So 7 plus 2 gives us 9 radical 3 as our final answer there. All right, let's take a look at 8. 20 and a 5, not the same. So can we reduce a radical 20? Yes. What perfect square again? 4. And then it's 4 times 5 gives us 20, so I put 5 in my second radical. Square root of 4 is 2. And again, I have to do it times that 3 that was already out in front. So we get 6 radical 5. Our other one is a 2 radical 5. Can we simplify that any further? No. So I'm just going to bring that down and line it up with my other one. So I have my 6 radical 5 plus my 2 radical 5. So what's our final answer? 8 radical 5. All right, so again, looking at 9, don't have the same radicals. I got a 3 and a 27. We know we can't reduce a 3, but we can reduce a 27. What's our perfect square that goes into 27? 9. And then what goes in the other radical? 3. Very good. So our square root of 9 is a 3. And then we have to do it times that negative 2 that was already out in front. So negative 2 times 3 gives us a negative 6 radical 3. And again, I'm going to bring down that first one, that 3 radical 3. I've got to keep that one there. So what's our final answer? Negative 3 radical 3. If we take a look at 10, they love to use these kinds of questions to kind of try to trick you. 25, we can't break down because what is 25 already? Perfect square. 25 is already a perfect square. We do the 2 radicals for the other ones because they're not perfect squares. This is already what we want. Square root of 25 is just a 5. So I don't have to do anything further with that. Can we put a perfect square into 45? 9. So I'm going to break up my 45 into 9 and 5. The 9 comes out of the radical as a 3. I'm going to have to do it times the other 3 that was already there. So that gives me 9 radical 5. And then I have to bring down that plus 5 from the front. And you cannot combine those. Do not try to add those and tell me it's 14 radical 5. These are not like terms. There's no radical with that 5. This is kind of like if it was a 5 plus a 9x. Would you guys add those together and tell me 14x? No, you know not to do that. It's the same thing with a radical. No radical with that 5. You don't add it to the 9. All right, now these last 2, they look like a lot. But if you just go through each radical, simplify them, and then you'll be able to add at the end. So let's start with our 5 radical 32. 32 has more than one perfect square that goes into it. So remember, we have to find the largest one. What's our largest perfect square that'll go into 32? 8's not perfect. 16. 16 and 2. The other one that goes into it is 4. And a lot of people will find 4 first, but that's not the largest. You always got to remember to find the largest one. So 16 comes out of this radical sign as a 4. And then I have to do it times that 5 that was already out in front. So what do we get for that one? Perfect. So our 5 radical 32 reduces to 20 radical 2. Now let's go to the 50. What's our perfect square that goes into 50? 10's not perfect. All right, a couple people say it. 25. 25 times 2. What is the square root of 25? So we get 5 radical 2, and there's nothing to multiply the 5 times. So that stays as 5 radical 2. So then our last one, our 7 radical 8. What's our perfect square that goes into 8? 4. Very good. 4 times 2. 4 comes out of the radical as a what? 2. And then I have to do it times that negative 7. So I get a negative 14 radical 2 at the end. Now all 3 of them have a like radical. They're all radical 2's now. So now we can combine them. 20 plus 5 minus 14. What do we get? 11 radical 2. All right, one more in our notes. So for number 12, again, we have to go through and break each one of those down. So let's start with the 24, 5 radical 24. So I'm going to do 5 and then 2 radical signs. What's our largest perfect square that goes into 24? No, 12 is not perfect. Not 16. 4. I know 24 is tricky because a lot of people think it would be bigger than 4, but really 4 is our largest perfect square that goes into it. So 4 comes out of the radical as a 2. And then I have to multiply it times the 5. So we get 10 radical 6. for that first one. So I'm going to give you a minute. I want you to try to reduce your 4 radical 50 on your own. Let's see if you can get that one. 54 is always a tough one. Does anybody know the perfect square that goes into 54? 9. 9 times what? 6. Very good. So 9 comes out as a 3. And then I got to do it times the 3 that was already there. So that gives me a 9 radical 6. So now what happens, we have 2 different radicands here. We have a radical 6 and we have a radical 2. So that means we're going to have 2 radicals in our answers. You want to combine the 6's and then you want to combine the 2's. So 10 radical 6 plus 9 radical 6 would give us a 19 radical 6. And then negative 20 radical 2 minus 3 radical 2. What does that give us? Negative 23 radical 2. And that's your final answer. Now there's no specific order you would have to write those in, so just keep in mind you may see it written the other way as negative 23 radical 2 plus 19 radical 6. But it's the same thing. Sometimes they'll put the 2 first. There's really no rhyme or reason which one they're going to put first.